Let's look at question number 41 now, students. Energy levels E1, E2 and E3 of a hydrogen-like species are having energy in the order of E3 more than E2 more than E1. If lambda 1, lambda 2 and lambda 3 are the wavelengths of radiation emitted by an electron, when an electron comes to E2 from E3 and to E1 from E2 and to E1 from E3 respectively, then we have to comment on the relation which is correct. Okay. So we've been given three different energy levels, students. It is E3 more than E2 and more than E1. So if I talk about the wavelength involved, students, when the electron comes to E2 from E3, the radiation involved has a wavelength equal to lambda 1. Okay. When it comes to E1 from E2, it is lambda 2. And when it comes directly from E3 to E1, then it is lambda 3. Okay. So we know that, students, hc by lambda 3 shall be equal to hc by lambda 2 plus hc by lambda 1. So this implies that 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2. Or if we simplify this, we have lambda 3 equal to lambda 1 lambda 2 upon lambda 1 plus lambda 2. Okay. So if you look at the relations which are given to us, students, we can clearly see that the first option is correct, and for this question we have to mark the answer as option 1. Let us look at the next question now. Question number 42. At 100 degrees C, the gaseous reaction A giving us 2B and C is found to be of first order. Starting with pure A, if at the end of 10 minutes the total pressure of the system is 176 mm Hg and after a very long time it is 270 mm of Hg, we have to comment on the incorrect statements. Okay, so students, A was giving us 2B and C. Okay, let us assume that the initial pressure of A be equal to P naught. Okay, so this is time equal to 0. So T equal to 10 minutes. Let's say some amount of moles of A be dissociated, due to which the pressure is decreased by X units. So this will be 2X and this will be X. Okay, and after a very long time, all of this A will be converted into B and C. So this will be 2P naught and P naught. Okay. Students have been given two different informations. So the pressure after a very long time is 270 mm Hg. It means that this pressure is equal to 270 mm of Hg. Okay. So we have 3P naught equal to 270. It must mean that the value of P naught is equal to 90. Now if we solve for the value of X, students, so we have the pressure at the end of 10 minutes equal to 176 mm of Hg. So we have this pressure. Okay, so if we add these pressure, students, we're going to have P naught plus 2x, and that was equal to 176. Okay, if we put the value of P naught over here, so P naught value is 90. So it means that the value of 2x is equal to 86. It means that the value of x is equal to 43. Okay, so we talk about the pressure, students. So initial pressure of A was 90 mm Hg. The pressure of A after time 10 minutes is 90 minus 43, which is equal to 47. Okay. The value of 2x is 86 and the value of x is 43. And the value of 2P naught and P naught are 180 and 90 respectively. Okay. Let us look at the options now, students. Option 1, it says at the end of 10th minute the partial pressure of A is 47 mm of Hg. So this is the correct statement, students. To talk about second statement now, at the end of 10th minute partial pressure of C is 43 mm Hg. So this is also correct, students. To talk about third option now, at the infinite time partial pressure of B is 180 mm of Hg. So this is also correct statement, students. So to talk about the fourth option, it has to be incorrect. At the infinite time partial pressure of C is 43 mm Hg. So this is not correct, students. At the infinite time the partial pressure of C is 90. So students, for question number 42, we have to mark the correct answer as option 4. Let us look at the next question now, students. Question number 43. When a strong acid reacts with a strong base, considerable amount of energy is released, called as enthalpy of neutralization. An experiment is carried out in an adiabatic system in which 50 ml of 0.4 molar NaOH is titrated thermometrically with 0.1 molar H2SO4. So students, in thermometric titrations, the temperature is noted. Okay. Which of the following plot is correct for the above experiment? Assume that the temperature of NaOH solution and H2SO4 solution is same at the start of the reaction. Okay. So students, if we talk about the neutralization point, so at the neutralization point, the milliequivalents of both these species, the acid and the base, are going to be equal. So we have 50 into 0.4 equal to 0.1 into 2 into the volume of H2SO4 which was consumed. Okay. So if you talk about the value of V, students, it is going to be equal to 100. So the neutralization point will be when 100 ml of H2SO4 is added. Okay. So the neutralization point is 100 ml. Okay. Now if you talk about the temperature, students, since the reaction is carried out in an adiabatic system, so the heat will not be lost. So the heat will be trapped inside the system, and this will lead to an increase in the temperature of the system. Okay. So the temperature is going to increase up to the neutralization point, students, as can be seen from all of these graphs. Okay. So it will increase up to the neutralization point, and once the neutralization is done, students, further addition of H2SO4 is going to lead to a decrease in the temperature. So why is it going to cause a decrease in the temperature, students? Because the temperature of the solution is greater, but the temperature of the H2SO4 which we are adding, it was lesser. Okay. So due to the addition of a colder H2SO4 solution after the neutralization, the temperature is going to reduce. Okay. So the maxima should happen around the 100 ml. And if you look at the options which are given to us, students, we can clearly see that for this question we have to mark the correct answer as option 2. Let us look at the next question now. Question number 44. Consider the adsorption of a gas on a suitable adsorbent taking place at constant temperature but at different pressures. The examiner seems to be interested in the adsorption isotherms. Which of the following is correct for the above phenomena? Students, if I talk about the adsorption isotherm, we know that we have a graph of this nature. So option 1, it says at very high pressure the amount of adsorption increases linearly with the further increase in pressure. So this is not correct, students. At very high pressure the amount of adsorption almost becomes constant. So there is an asymptotic behavior. So it becomes almost constant. So it does not linearly increase. If we talk about the second option now, at very low pressure the amount of adsorption increases linearly with further increase in pressure. So this is a correct statement, students. At very low pressures we can see that the variation can be almost assumed to be linear. Okay. If we talk about the third statement now, delta G is positive for the adsorption at low pressure. This is not correct, students. It is negative. So that is why adsorption is a spontaneous phenomena. If we talk about option 4 now, delta G becomes more negative for the adsorption process if the pressure is increased after the equilibrium pressure. So this is not correct, students. It is becoming less negative and not more negative. Delta G being more negative is a favorable thing. So the second statement is correct, students, and for question number 44 we have to mark the correct answer as option 2. Let us look at the next question now. Question number 45. An aqueous solution of NaCl liberates H2 and Cl2 during electrolysis. An electrolytic cell is assumed to have 100% current efficiency and liberated 710 grams of Cl2. The volume of H2 liberated at cathode at STP is. Okay. Students, if I talk about the aqueous solution of NaCl, when it is electrolyte, it liberates H2 and Cl2. So the H2 comes from H2O, obviously. Okay. So if I talk about the reactions, I have Cl minus converting into Cl2 and losing an electron at the anode. If I talk about the cathode, students, the H2O is going to consume the electron and it is going to convert into H2 and OH minus. Okay. So from this reaction, students, we can clearly see that for every 1 mole of electron, there is half mole of Cl2 and half mole of H2 which is getting evolved. It means that the moles of Cl2 and H2 are going to be equal. Okay. So if we talk about the moles of Cl2, students, it is given to us that 710 grams of Cl2 is evolved. It means that there are 10 moles. So it means that there are 10 moles of H2 as well. So if I talk about the volume at STP, students, it is going to be 22.4 times the number of moles. So this shall be equal to 224. So students, if I talk about this question, we have to mark the correct answer as option 3. Let us look at the next question now.